Hello viewer, it's another video on thermodynamics lecture series. If you are interested in the topic first law of thermodynamics, sit relaxed, make yourself comfortable, watch, enjoy and learn. Over to the topic now.
Consider a system and the temperature of the system is measured using a thermometer and it is found to be equal to the atmospheric temperature. That means the system is initially at atmospheric state. The state of the system can now be plotted in a chart. X and Y are any two properties of the system, and the initial state, which is equal to atmospheric condition, is plotted. Now, suppose if we insulate the system, and introduce a paddle wheel arrangement. So this is what a paddle wheel arrangement, and due to the lowering of weight, we are going to observe simultaneously what happens to this wheel, what happens to this thermometer reading, and what happens to this process. So when this weight falls down, the wheel will rotate and the thermometer temperature reading will change and the state of the system also will change. So observe simultaneously, it is falling down, rotating, the temperature keeps on increasing and the state is changing and it reaches the final state 2. Why the system state is changed? Because the temperature rises. Therefore, we say the system has undergone a change of state. Why this change? It is because of paddle wheel work. The work is done on the system. The system is insulated and hence there is no heat transfer. But energy in the form of work crosses boundary. Remember, we discussed earlier, heat and work are the forms of energies that crosses system boundary. In our example, due to this paddle wheel work, energy in the form of work crosses boundary. As we said earlier, what about this heat? The system is insulated. There is no heat transfer, hence, across the system. But we noticed a rise in temperature reading on the thermometer. So temperature but rises. Why? Why it rises? The movement of the paddle wheel, that is the rotation of the paddle wheel, agitates the molecules present inside the system, and hence the randomness or disorderly movement of the molecules present in the system increases. So the disorderly movement may contribute to rotational kinetic energy, translational kinetic energy, vibrational energy in microscopic form. So this microscopic form of energy is internal energy, we already discussed. So that is the reason for the rise in temperature. So the molecular activity is increased. Internal energy of the system is a function of temperature only for an ideal gas. So that is the reason the temperature rises. Now, what can we say here is, in the absence of heat transfer, the only mode of energy that crosses the system boundary is work. That is the paddle wheel work. Because of that, the internal energy is raised or increased. How do we know the internal energy has increased? Because the temperature of the system increased. And hence we can say energy is stored in the system, therefore. So energy means internal energy is stored. Work and heat cannot be stored in the system. They are dynamic forms of energy. Therefore, energy is balanced or conserved during the process. So there is a change of state. We assume the process is quasi-static. Therefore, the path is clearly defined. So 1 to 2 is a process. And during this process, energy is balanced. And we already studied energy in minus energy out is equal to delta E of the system. So the net energy transfer is equal to the change in energy of the system. So what is the net energy transfer? There are only two forms of energy that can be transferred in a closed system. One is heat, another one is work. Therefore, we can write here, for this example, Q minus W equal to del E. The question now is why minus W? Because work done on the system is negative. The paddle wheel is doing work on the system, therefore it is taken as minus. It represents the direction, not the quantity, negative sign. And the system is insulated, therefore Q is 0. We can write then minus W equal to del E. We can write minus W equal to del E, meaning one form of energy, work, that is the paddle wheel work, done on the system is stored in the system. That's why energy is balanced or conserved. That is law of conservation of energy. The equation we discussed in the previous slide can be rearranged like this. Q equal to W plus del E. So Q minus W equal to del E we discussed. Instead, we can write Q equal to W plus del E. So Q is the heat, W is the work transfer, E is the energy, or del E is the energy change. In general, for a system, that means especially a closed system, that involves multiple heat transfer and work transfer, we can write sigma of Q equal to sigma of W plus del E. In this example, the sigma Q and sigma W can be rewritten like this: Q1 plus Q2 plus Q3 minus Q4. Why minus Q4? Observe the direction of the arrow. In Q4, heat is rejected by the system, or heat flows from the system to the surroundings. So heat rejected by the system is taken as negative. Heat added to the system, Q1, Q2, Q3, Q5 are positive. So Q6 rejected, therefore it is minus. And that is equal to sigma W. Instead of sigma W, we can write minus W1 plus W2 minus W3 plus W4, sorry, minus W4 minus W5. Why? Work done on the system is taken as negative. So W1, look at the direction, done on the system, therefore it is negative, minus W1. Whereas the direction of W2 is towards the surroundings. That means this is the work done by the system. Therefore, it is positive, plus del E. And this equation represents first law for a system undergoing a process. Undergoing a process. So first law is nothing but a law of conservation of energy. So we need to make use of this equation to solve numerical. So first law of thermodynamics for a system undergoing a process or undergoing a change of state. Instead of process, here I used words change of state. Now the thing is, what is first law for a system undergoing a cycle? So first law of thermodynamics for a system undergoing a cycle. Earlier we discussed change of state or the process 1 to 2. Initial state is changed to state 2 due to the paddle wheel work done on the system. Suppose if you remove this insulation, if this insulation is removed, the system will reject the heat to the surroundings. That means the atmosphere. Surrounding is nothing but the atmosphere. The temperature of the system due to paddle wheel work is higher than the temperature of the atmospheric air. Heat always flows from a body at higher temperature to a body at lower temperature. Therefore, the system at higher temperature will reject the heat to the surroundings, and because of that, it returns to its original state after some time. So the state is returning and it is rejecting heat. So once again, there is a change of state. So once this insulation is removed, heat flows to the surroundings and the state of the system changes again and it reaches state 1, meaning it returns to the initial state, which is nothing but the atmospheric condition. And the change of state 1 to 2, the other change of state 2 to 1 are represented using arrows. So this is 1 to 2, this is 2 to 1. So 1 to 2 constitute process 1 and 2 to 1 constitute process 2, and process 1 and 2 together constitute a cycle. System at state 1 changes to state 2 and it returns to state 1. There are two different parts, two processes. Therefore, the system is said to have undergone a cycle. Now, what we can say is the system has undergone a cycle. And in process 1 to 2, work 1 to 2 is done on the system, paddle wheel work. In process 2 to 1, Q1 to 2, that is heat, is rejected by the system. We can write work done is proportional to heat transfer. So this is written based on number of experiments. And to remove this proportionality constant, to remove this proportionality, we introduce a constant J. So J is Joule's equivalent or mechanical equivalent of heat. Therefore, first law, for a system undergoing a cycle can be written as sigma W during the cycle is equal to J, that is the Joule's equivalent, multiplied by sigma Q during the cycle. So the definition for the first law of thermodynamics for a system undergoing a change of state and for a system undergoing a cycle are studied. And this first law says energy is conserved, that is fixed, during the process. The question now is whether energy is a point function or path function. Earlier we discussed work and heat are path function. Now Q is equal to W plus del E. Therefore, whether E is a path function or point function, we need to learn. So what is that? Energy is a property of the system. When you say property, it clearly says it is a point function, independent of path. To prove this, consider energy, a quantity that depends on path. So assume it as path function initially. But the title of the slide says it is a property of the system. Now we are going to disprove our assumption. What is our assumption? Initially we are assuming energy as a path function. Now we are going to make use of first law of thermodynamics. So in the plot we have two processes, process 1 to 2 and process 2 to 1. For process 1 to 2, we can write Q1 to 2 is equal to del E1 to 2 plus W1 to 2. Here we are assuming energy as a path function. Therefore, we are not writing E1 minus E2. We are writing del E1 to 2. Similarly, for process 2 to 1, we can write Q to 1 is equal to del E2 to 1 plus W2 to 1. And now process 1 and 2 together constitute a cycle. And we know for a system undergoing a cycle, sigma W is equal to sigma Q. So this can be written like this: W122 plus W221. That means the work done. Work done during the process 1 to 2 plus work done during the process 2 to 1 is equal to heat transfer during process 1 to 2, heat transfer during process 2 to 1. This equation can be rearranged like this. Why we rearranged it like this? Come over here. The equation for process 1 to 2 can be rearranged like this. Similarly, the equation for process 2 to 1 can be rearranged like this. Now compare W21 minus Q21 with this one, and Q122 minus W122 with this one, meaning, so these two are same. Similarly, these two are same. That's why we rearranged this equation. We rearranged this equation in this form. So W221 minus Q221, which is nothing but this one, and hence, instead of this, we are going to substitute this one. Instead of this, we are going to substitute this one. Similarly, for this one, we are going to substitute this. From this, what we infer is del E 2 to 1 is equal to del E 1 to 2, meaning the change in total energy of the system is same for the process 1 to 2 and 2 to 1. But there is a negative symbol here that represents only the direction. Symbol represents only the direction. The quantities are same. Del E21 is equal to del E12. Quantities are same, but the direction is different. And hence, change in total energy of the system is independent of the path followed. So 1 to 2 is this one, 2 to 2, 2 to 1 is this one. So the change in total energy is independent of the path, and hence it is a point function. So when you say a point function, it is a property, and energy is a property which depends on mass of the system, and hence it is an extensive property. So using first law of thermodynamics, we proved energy as a property of the system.
Now, the takeaways from the lecture, first law of thermodynamics. We learned first law applied for a thermodynamic system undergoing a change of state and a cycle. First law for a system undergoing change of state is mathematically given as sigma of Q is equal to sigma of W plus del E, where E is the energy of the system. Q and W are the work transfers. And for a cycle, first law mathematically is expressed as sigma of work done for the whole cycle is equal to J multiplied by sigma of Q for the whole cycle. So J is a constant. In order to remove the proportionality between work and heat in a thermodynamic cycle, remember work and heat are energy quantities. A thermodynamic system interacts with the surroundings through work and heat transfer. And from this, first law says energy is conserved. So it is something law of conservation of energy. And energy, E, is an extensive property of the system, meaning energy depends on the mass of the system. Thank you.